Welcome to Unsolved Historical Mysteries. Did they really exist? The mysterious extinction of the Neanderthals. The story of the Neanderthals begins in 1856, with an accidental discovery in Germany's Neander Valley. Workers in a limestone quarry stumbled upon bones that seemed human, but were thicker and more robust than expected. These fossils were later identified as belonging to an ancient human species, and they changed our understanding of human evolution forever. Known as Homo neanderthalensis, or simply Neanderthals, they are our closest known relatives on the human family tree, believed to have evolved around 400,000 years ago in Europe and parts of Asia. But what do we know about these ancient humans? Let's start with their physical characteristics. Neanderthals had a body structure much more robust and muscular than that of modern humans. Their bones were thick and sturdy, a clear adaptation to the cold and harsh environments of the Ice Age that defined their era. Scientists believe these physical traits, including broad chests and shorter limbs, were an evolutionary response to retaining body heat and surviving in colder climates. Unlike the more slender build of modern humans, the Neanderthals' form was well suited to the demands of their environment. Facially, Neanderthals had some distinct features too. Their skulls were low and elongated with a prominent brow ridge, while their noses were large and wide, likely adapted for warming the cold, dry air before it reached their lungs. This combination of facial traits gave Neanderthals a unique look, one that may seem unusual to us, but was essential for their survival in such extreme climates. Their brains, interestingly, were on average the same size or even slightly larger than ours today. This has led to intriguing questions about their cognitive abilities and culture, while we're not entirely sure how they thought or what they might have believed. Recent studies suggest that Neanderthals were far from the unsophisticated cavemen stereotype that once dominated popular views. Evidence has shown that they created tools, cared for injured group members, and even buried their dead, a behavior associated with symbolic thinking and possibly a belief in some form of afterlife. This complexity is further supported by discoveries of Neanderthal tools, which show a high degree of skill and specialization. They crafted tools from stone and bone, used fire for warmth and cooking, and likely had a diet that included both plant-based and animal foods. There is also evidence that they wore clothing made from animal hides, although whether they stitched them or used simple wrappings is still debated. So, who were the Neanderthals? Far from being primitive beings, they were intelligent, resilient, and resourceful. The more we learn about them, the clearer it becomes that Neanderthals were not so different from us after all. Their story, starting from a handful of bones in a valley, has evolved into one of the most fascinating chapters of human history. A reminder that our journey as a species is deeply intertwined with that of our ancient cousins. One of the most captivating questions about Neanderthals is just how similar or different they were to us, modern humans. While many people still picture them as primitive cavemen, recent findings suggest that Neanderthals shared far more in common with us than previously believed. Let's explore some of these similarities, as well as a few striking differences. To begin with, Neanderthals and modern humans both belong to the genus Homo, which means that we share a common ancestor. Scientists estimate that our evolutionary paths diverged roughly 500,000 to 700,000 years ago, with Neanderthals evolving to adapt to the colder climates of Europe and Asia, while modern humans continued to develop in Africa. Despite this long separation, studies of Neanderthal DNA show that we share over 99% of our genetic makeup. This genetic closeness is one of the reasons why, when modern humans eventually migrated to Europe, they were able to interbreed with Neanderthals, a process that left traces of Neanderthal DNA in many people alive today. Now, in terms of physical similarities, both Neanderthals and modern humans had complex hands with fine motor skills, capable of making tools and manipulating objects in intricate ways. They also had comparable brain sizes, although the Neanderthal brain was structured slightly differently, particularly in regions associated with visual processing and body control. This likely reflects adaptations to their environment, where quick responses and spatial awareness were crucial for survival. When it comes to behavior, the overlap is even more intriguing. Evidence shows that Neanderthals created tools, used fire, cooked food, and likely built shelters. They even cared for injured or sick group members, suggesting that they had a social structure based on empathy and cooperation. Some studies have found that Neanderthals buried their dead and decorated objects, hinting at cultural practices and possibly even symbolic thinking, traits that we once believed were unique to modern humans. However, there were some notable differences as well. Neanderthals were generally shorter and stockier than modern humans, with a more robust bone structure that was well suited to their colder, harsher environments. They also lacked some of the technological advancements that modern humans later developed, such as complex language and the use of long-distance hunting tools like the bow and arrow. Neanderthals used a simpler range of tools, compared to the diversity seen in early Homo sapiens artifacts, which might indicate different levels of innovation or cultural development. So, while Neanderthals were undoubtedly distinct, their similarities with us are profound. Far from being completely alien, they were a close cousin, with intelligence and social bonds that parallel our own. Understanding these connections gives us valuable insight not only into their lives, but also into what it means to be human. Through our shared ancestry, Neanderthals provide a unique mirror, reflecting some of the very traits we value in ourselves today. To truly understand the Neanderthals, we must look at the environment they called home, a world shaped by harsh conditions, unforgiving landscapes, and rapidly changing climates. Neanderthals thrived across vast stretches of Europe and parts of Western Asia during the last ice age, facing a landscape that was far colder and less hospitable than most places where humans live today. Around 200,000 years ago, when Neanderthals first began to appear in Europe, the climate fluctuated between warmer interglacial periods and extreme cold spells known as glaciations. During the colder phases, thick sheets of ice covered much of northern Europe, while open grasslands and tundra dominated the regions where Neanderthals lived. This environment was home to large herbivores like mammoths, woolly rhinos, and giant deer, which Neanderthals relied on for sustenance. Hunting these powerful animals required strength, coordination, and cooperation, all of which were crucial to their survival. One of the ways Neanderthals adapted to their environment was through their physical build. As we've seen, they were shorter and more muscular than modern humans, with a robust frame that conserved heat more effectively, ideal for surviving in frigid climates. Their large nasal cavities were also an adaptation, as they helped warm the cold air before it reached their lungs, preventing respiratory issues in freezing temperatures. Beyond just physical adaptations, Neanderthals developed survival strategies that helped them thrive. In this rugged environment, archaeological evidence suggests they created temporary shelters, likely using caves or simple structures, built from bones and hides to protect themselves from the cold. They mastered fire, which provided warmth, allowed them to cook meat, and may have helped ward off predators at night. They also utilized locally sourced stones to craft tools for hunting and processing animals, showing an impressive level of resourcefulness and adaptability. But despite their remarkable adaptations, the Ice Age environment was not easy to endure. Neanderthals faced constant challenges, from limited food resources to unpredictable weather patterns. The scarcity of edible plants in colder seasons meant they relied heavily on a meat-based diet, which in turn required frequent hunting. This environment likely forced them to stay on the move, following herds of animals and seeking out new resources whenever food became scarce. In the end, the environment shaped every aspect of Neanderthal life. From their physical traits to their social behaviors, they were a people molded by the Ice Age, uniquely adapted to endure some of the toughest conditions Earth had to offer. However, as the climate continued to change, new challenges emerged. Challenges that ultimately may have contributed to their decline. But for tens of thousands of years, the Neanderthals not only survived but thrived in a world that tested them to their limits, leaving a lasting legacy that echoes through human history. One of the leading theories about the extinction of the Neanderthals is that they simply couldn't keep up with the extreme and rapid climate changes of their time. The Neanderthals survived multiple ice ages, but around 40,000 years ago, they faced a series of increasingly harsh climate shifts, which may have proved too difficult for them to endure. To understand how climate change impacted their survival, we need to look at the changing landscapes and the effects these shifts had on their way of life. As the last ice age reached its peak, temperatures in Europe and Asia dropped significantly, creating environments even colder and more hostile than before. Large glacial sheets spread across Europe, while elsewhere, temperatures fluctuated drastically. In such a world, the Neanderthals' traditional hunting grounds and habitats would have been heavily disrupted. The landscapes they were accustomed to, open woodlands and grasslands that supported large herbivores, like mammoths and bison, began to shrink, replaced by barren tundra where food sources were sparse. With dwindling food supplies and disappearing animal herds, Neanderthals faced severe challenges in meeting their dietary needs. Although they were skilled hunters, the lack of animal resources likely forced them into competition with each other and with incoming modern humans. Modern humans had more advanced hunting tools and techniques, which might have given them an advantage in securing scarce resources. These pressures would have added up, making survival increasingly difficult for Neanderthal groups scattered across Europe and Asia. But food shortages weren't the only impact of climate change. Studies of archaeological sites showed that Neanderthals had relatively simple shelters compared to those of early Homo sapiens. While they often used caves and temporary structures, the extreme cold of the glacial periods demanded more robust shelters to protect against the elements. Modern humans, by contrast, are believed to have used more sophisticated clothing and shelter building techniques, which may have allowed them to adapt more flexibly to colder climates. In the face of these challenges, Neanderthals likely had to migrate frequently, seeking better conditions and more resources. However, constant movement would have made it difficult to establish stable communities, and it likely disrupted their social structures and cooperation. Under such pressure, even small populations would have struggled to maintain their numbers, making the entire group vulnerable to extinction over time. Ultimately, the climate was an adversary. that Neanderthals had little control over. Their physical adaptations and skills, while remarkable, may not have been enough to survive the severe changes that reshaped their world. Climate change alone may not fully explain their extinction, but it likely played a major role, creating conditions that left them exposed to further challenges. And as we'll see in the next sections, these challenges were compounded by the arrival of modern humans, as well as other factors that pushed Neanderthals to the brink. Another compelling theory for the Neanderthals' disappearance is rooted in their encounters with modern humans, or Homo sapiens. Roughly 50,000 to 40,000 years ago, early humans began migrating from Africa into Europe and Asia, regions already populated by Neanderthals. What followed was likely a period of intense competition, and, surprisingly, interbreeding between these two human species. This complex relationship of rivalry and mixing might hold the key to understanding why Neanderthals ultimately vanished. One of the primary factors in this competition was resource access. Both Neanderthals and modern humans were hunter-gatherers, relying on the same animals and plant resources for survival. As Homo sapiens arrived, they brought with them advanced tools and hunting techniques. For example, they used more refined stone tools, such as blades and projectile weapons, which allowed them to hunt more efficiently. These innovations likely gave them an edge in hunting large game, forcing Neanderthals into even fiercer competition for food. In addition to tools, modern humans were also more adaptable in their social structures. Evidence suggests they had larger and more organized social groups, which allowed for better communication, resource sharing, and collaborative hunting. This social adaptability may have helped Homo sapiens thrive in varied environments, while Neanderthal groups remained smaller and more isolated. In situations of limited resources, such social networks would have been essential to survival, giving early humans a significant advantage. But competition wasn't the only outcome of this meeting. Between species interbreeding also occurred, as evidenced by the Neanderthal DNA that many people today carry in their genomes. Around 1 to 2% of the DNA in modern non-African populations can be traced back to Neanderthals, suggesting that interbreeding was relatively common. This genetic exchange didn't just blur the lines between species. It also provided modern humans with genetic advantages. Some studies suggest that Neanderthal genes may have helped early humans adapt to Eurasian climates, giving them immunity boosts or adaptations to colder weather. However, this blending of DNA didn't necessarily benefit the Neanderthals. As modern human populations grew, they might have gradually absorbed and replaced smaller Neanderthal groups. This process, known as genetic swamping, occurs when a smaller population interbreeds with a larger one, until its unique genetic traits diminish. Over time, Neanderthals may have been slowly absorbed into the growing Homo sapiens population, rather than simply being wiped out. In the end, the arrival of modern humans presented both a direct and indirect threat to Neanderthal survival, with competition over resources, advanced social networks, and the complex dynamics of interbreeding. Homo sapiens' arrival in Europe and Asia may have placed an insurmountable burden on Neanderthal communities. Their story didn't end with a single event, but rather through a gradual decline, as interbreeding and competition chipped away at their populations. It's a reminder of how intertwined the histories of these two species truly are, and how the legacy of Neanderthals lives on in the DNA of people across the world today. In addition to climate shifts and competition with modern humans, Another factor that may have contributed to the extinction of Neanderthals is disease. As Homo sapiens migrated into Europe and Asia, they likely carried with them pathogens to which Neanderthals had little to no immunity. The introduction of new diseases could have spread rapidly through Neanderthal populations, devastating their communities in ways that neither their physical resilience nor their cultural practices could protect against. There is evidence that early humans and Neanderthals exchanged not only genes but also illnesses. Researchers believe that diseases such as tuberculosis, herpes, and stomach ulcers may have been introduced by modern humans into Neanderthal populations. These pathogens would have been entirely new to the immune systems of Neanderthals, potentially leading to deadly outbreaks. When small, isolated communities face new diseases, even a mild illness can have catastrophic consequences, especially if these communities lack the social or medical structures to respond effectively. Moreover, Neanderthals already faced environmental stressors that made their survival challenging. As we've seen, the fluctuating climate during the Ice Age led to constant changes in the ecosystems they depended on. The shifting environment forced them to continuously adapt to new landscapes and food sources. This alone would have been demanding, but when combined with the threat of disease, it may have been more than Neanderthals could endure. Some researchers suggest that environmental stress could also have weakened Neanderthals' immune systems, making them even more vulnerable to infections. Nutritional deficiencies due to limited food resources, exposure to harsh weather, and frequent migration likely placed a heavy toll on their physical health. Weakened by these environmental challenges, Neanderthal populations may have been less capable of recovering from disease outbreaks, further accelerating their decline. Another environmental factor was the gradual transformation of their habitats. As glaciers receded, the open woodlands and grasslands that Neanderthals were accustomed to began to change, giving way to denser forests that were better suited to the hunting techniques of Homo sapiens. As the landscape evolved, Neanderthals may have found it increasingly difficult to locate food, especially the large herbivores that had once been their primary food source. This shift would have made life even harder, forcing Neanderthals to compete more directly with modern humans for resources in an environment that no longer favored their way of life. In the end, it's likely that no single factor caused the Neanderthals' extinction. Instead, it was a combination of climate change, disease, and environmental transformation that gradually wore down their populations. The arrival of modern humans only added to these pressures, creating a situation in which Neanderthals faced multiple challenges from all sides. Together, these factors led to the eventual disappearance of Neanderthals from the archaeological record. Their legacy, however, lives on, not only in the traces of DNA found in modern humans, but also in the lessons they provide about resilience, adaptation, and survival in the face of overwhelming odds. One of the most remarkable discoveries in recent decades has been the genetic link between Neanderthals and modern humans. Thanks to advances in genetic technology, scientists have been able to extract and sequence DNA from Neanderthal fossils, revealing surprising insights into how closely connected we actually are to these ancient relatives. Today, it's known that non-African populations carry between 1 to 2% of Neanderthal DNA, a testament to the shared history between our species. But what exactly does this genetic connection mean? First, it shows that Neanderthals and Homo sapiens didn't just coexist. They interbred during periods of contact. As Homo sapiens migrated out of Africa and into Neanderthal inhabited regions in Europe and Asia, these interactions led to genetic mixing, which has left traces that persist in the human genome to this day. These findings challenge the earlier view of Neanderthals as an entirely separate species, suggesting instead a complex relationship that includes not only competition, but also cooperation and integration. The Neanderthal DNA present in modern humans affects more than just our ancestry. It has a tangible impact on our biology. Some studies have shown that genes inherited from Neanderthals influence various traits in modern humans, including skin pigmentation, hair color, and even aspects of immune response. For example, certain immune system genes linked to fighting off infections are believed to have originated from Neanderthal DNA, possibly providing an advantage to early humans as they adapted to the new environments of Europe and Asia. In this sense, Neanderthals contributed directly to the survival and adaptability of their Homo sapiens descendants. However, the influence of Neanderthal DNA is not entirely beneficial. Research has also linked certain Neanderthal genes to a predisposition for specific health conditions, including autoimmune diseases, type 2 diabetes, and even nicotine addiction. This dual impact, where Neanderthal genes can offer both advantages and vulnerabilities, highlights the complex ways in which ancient genetics continue to shape human health and behavior today. Ultimately, the shared DNA between Neanderthals and modern humans is more than just an evolutionary curiosity. It reveals a story of two species that weren't entirely separate, but rather shared intimate connections over thousands of years. This blending of lineages has left a lasting legacy that continues to affect us, shaping aspects of our biology in ways scientists are still uncovering. Neanderthal DNA serves as a reminder that our evolutionary journey is not a solitary path, but one intertwined with the lives of our ancient relatives, connecting us across vast stretches of time. The genetic legacy of Neanderthals extends beyond mere ancestry. These genes actively influence certain aspects of modern human health, physiology, and even behavior. When modern humans and Neanderthals interbred, the resulting genetic exchange left us with DNA that continues to shape our lives in various ways. Scientists have only recently begun to understand the full scope of this influence, and their discoveries reveal some surprising connections between us and our ancient relatives. One of the most significant areas affected by Neanderthal genes is our immune system. As Homo sapiens migrated out of Africa into new environments, they encountered unfamiliar pathogens. Neanderthal DNA played a crucial role here, as it included immune-related genes that had already adapted to the pathogens present in Eurasian climates. These genes likely helped early humans fend off illnesses that would have otherwise posed severe threats to their survival. In fact, some modern humans still carry Neanderthal-derived immune genes that are associated with enhanced responses to viral infections, giving us an inherited resilience against certain diseases. But Neanderthal genes don't just affect our immune defenses. They also impact our skin, hair, and even susceptibility to specific health conditions. For example, Neanderthal DNA has been linked to variations in skin tone and hair color, traits that may have helped early humans adapt to the lower sunlight levels in Europe and Asia. Additionally, researchers have found that Neanderthal genes can influence skin's ability to repair itself and react to UV radiation, which would have been valuable traits for populations adapting to varied climates. Interestingly, Some Neanderthal genetic variants have been associated with conditions that affect people today. Certain autoimmune diseases, including lupus and Crohn's disease, appear to be influenced by Neanderthal DNA. This occurs because immune system genes that evolved to protect Neanderthals from specific infections can, in a modern context, mistakenly target the body's own cells, leading to autoimmune responses. Similarly, genetic links have been identified between Neanderthal DNA and conditions like type 2 diabetes and even a tendency for nicotine addiction. These findings suggest that, while Neanderthal genes offered evolutionary advantages in the past, they can present challenges in today's vastly different environments. Overall, the Neanderthal genes within us are a double-edged sword. They represent both an ancient solution to survival in harsh climates and a source of modern health complications. This legacy, however, underscores the complex relationship between adaptation and change. Through the genes they left behind, Neanderthals continue to influence the lives of their Homo sapiens descendants, shaping our physical and biological responses in ways that speak to our shared journey. Our connections to Neanderthals are not just buried in ancient bones but alive in our DNA, a reminder of how intertwined our histories truly are. For a long time, the story of the Neanderthals was seen as a tale of extinction, a species that once thrived, only to vanish in the face of overwhelming challenges. But recent research offers a different perspective. Rather than disappearing completely, Neanderthals may have merged with modern humans, living on in our genes and influencing who we are today. This idea of fusion rather than extinction reshapes how we view our ancient relatives and their legacy. One of the strongest pieces of evidence supporting this view is the presence of Neanderthal DNA in non-African populations around the world. By interbreeding with early Homo sapiens, Neanderthals effectively passed down parts of their genome to future generations. This genetic blending wasn't an isolated event but likely happened over thousands of years. As small populations of Neanderthals and early modern humans interacted, shared resources, and sometimes formed familial bonds. Through this continued mixing, Neanderthal traits gradually became part of the Homo sapiens lineage, integrating their legacy directly into our own. Seeing Neanderthals as merged rather than extinct challenges the traditional view that they were entirely replaced. In this new interpretation, Neanderthals didn't simply vanish, but rather became part of the larger human story, with their genetic contributions spreading across generations. Traits and adaptations that evolved to help Neanderthals survive in Eurasia's unique climates became embedded in modern human DNA. In essence, they left behind a legacy that continued to aid our species in adapting to new environments and challenges. This perspective also invites us to rethink what it means for a species to survive. Rather than physical continuity, survival can sometimes mean passing on knowledge, traits, and adaptations. For the Neanderthals, their survival story is one of integration and influence. As modern humans moved into new regions, Neanderthals helped equip them, even if unknowingly, with the tools they'd need to succeed in those places. In a way, Neanderthals became an invisible yet powerful part of human evolution, shaping our journey from within. The Neanderthals' story, then, is not solely one of extinction. Instead, it's a story of connection and continuity, a fusion that links our species together across the millennia. Rather than seeing them as a lost branch on the human family tree, we can see Neanderthals as an enduring part of our own lineage. Their influence still present in each of us today, Through this merging interpretation, we come to understand that our connection to Neanderthals is not just an ancient curiosity, but a vital part of the human experience, illustrating how different human species can come together, shaping one shared legacy. In recent years, archaeological research has provided fascinating new insights into the Neanderthals and the mystery surrounding their extinction. As researchers uncover additional evidence, from tools to shelters to signs of cultural practices, our understanding of Neanderthals continues to evolve, challenging earlier theories about their lives and eventual disappearance. Some of these recent discoveries are rewriting what we thought we knew, offering fresh clues that may help explain the fate of this ancient human relative. One of the most remarkable finds has been the evidence of complex tool use among Neanderthals. Archaeologists have uncovered advanced stone tools in sites across Europe that indicate a level of skill and innovation previously underestimated. These tools suggest that Neanderthals may have been more adept at adapting to their environment than previously thought, possessing the skills to hunt, process food, and survive in a variety of habitats. This adaptability implies that Neanderthals had a sophisticated understanding of their surroundings, contradicting the once common stereotype of them as primitive or unsophisticated. Another discovery challenging previous assumptions is the evidence of symbolic behavior among Neanderthals. For instance, researchers have found items like pierced shells and pigments at several Neanderthal sites, which may have been used for body adornment or as part of rituals. Such artifacts suggest that Neanderthals may have had a sense of self-expression, or even spiritual beliefs, behaviors once thought unique to Homo sapiens. These findings point to a rich cultural life that likely helped Neanderthals form social bonds and adapt to their challenging environments. In addition, new archaeological techniques are shedding light on Neanderthal diet and mobility. Isotope analysis of Neanderthal bones has revealed that their diets were more varied than we once believed. While they primarily relied on large game, they also consumed plant materials and even seafood, depending on their geographic location. This dietary flexibility would have been crucial for survival, particularly in regions where food sources were seasonally scarce. Such insights challenge the notion that Neanderthals were rigid in their habits, suggesting instead that they were adaptive and resourceful. Together, these archaeological discoveries highlight a picture of Neanderthals as intelligent, culturally complex, and adaptive individuals. This evolving understanding raises further questions about their extinction. If Neanderthals were so capable, what factors ultimately led to their decline? As we continue to uncover new evidence, the mystery of Neanderthal extinction becomes less about a lack of ability and more about a complex interaction of environmental challenges, competition, and perhaps even cultural blending with Homo sapiens. Each new finding brings us closer to understanding not just how Neanderthals lived, but also the diverse strategies they used to navigate their world. The question of why Neanderthals went extinct while Homo sapiens survived is complex, and one area that researchers are focusing on is the difference in survival strategies between the two species. Although Neanderthals were highly adapted to their environments, their approach to survival may have been less flexible than that of early modern humans. These strategic differences, especially in terms of adaptability and innovation, may have ultimately influenced the fate of Neanderthals. One key difference was in group size and social organization. Neanderthals tended to live in smaller, more isolated groups, often spread out over large areas with limited interaction between communities. This isolation may have made it difficult for Neanderthals to share knowledge, resources, or tools widely, potentially slowing down innovation or adaptation to changing conditions. By contrast, early Homo sapiens often lived in larger groups with more interconnected networks, which facilitated the exchange of ideas, tools, and strategies. This social cohesion likely provided a critical advantage when facing new challenges. Another difference lies in the types of tools and technologies each species used. While Neanderthals developed sophisticated stone tools suited to their needs, they didn't demonstrate the same level of technological diversity seen in early modern humans. For example, Homo sapiens used a variety of hunting tools, such as spears and even early versions of bows, which allowed for more flexible hunting strategies. They also developed more advanced clothing and shelters, offering better protection from the elements. These technological innovations may have helped early humans survive in a wider range of environments, giving them a crucial edge as they spread into new territories. Dietary strategies also varied between the two species. Neanderthals relied heavily on large game animals like mammoths and bison, a strategy that served them well during stable climates, but became a vulnerability during times of environmental change. When large herbivores became scarce, Neanderthals may have struggled to adapt their diet accordingly. In contrast, Homo sapiens showed a greater ability to diversify their food sources, including small animals, fish, and plants, allowing them to be more resilient to shifts in climate and habitat. This dietary flexibility likely contributed to the survival and expansion of early human populations. In the end, the fate of the Neanderthals may not have been due to a lack of intelligence or adaptability, but rather to differences in how each species responded to the world around them. While Neanderthals excelled in specific environments with specialized survival skills, Homo sapiens' broader, more flexible strategies enabled them to endure environmental fluctuations and spread across diverse landscapes. These contrasting approaches to survival, shaped by both biological and cultural factors, highlight the nuanced paths that human evolution has taken. The Neanderthals' specialized survival strategies served them well for tens of thousands of years, but may have ultimately limited their ability to adapt to the rapidly changing world they faced. As researchers continue to uncover new information about the Neanderthals, the potential for solving the mystery of their extinction becomes increasingly promising. Advances in genetic technology, archaeological methods, and interdisciplinary studies are shedding new light on Neanderthals' lives, offering clues that were once unimaginable. Today, scientists are more optimistic than ever that they can finally answer the age-old question: why did the Neanderthals disappear? One of the most exciting developments has been in ancient DNA research. By extracting DNA from Neanderthal fossils, scientists have not only traced their genetic connections to modern humans, but also gained insight into their health, adaptability, and interactions with early Homo sapiens. Genetic studies continue to reveal how Neanderthals responded to diseases, climates, and environmental pressures. With each new discovery, we get a step closer to understanding whether their extinction was due to genetic vulnerabilities, interbreeding, or external pressures like competition and disease. Another promising area is the use of improved archaeological techniques. Advanced dating methods, such as radiocarbon dating refinements, allow researchers to build a more accurate timeline of Neanderthal presence in different regions. Additionally, new imaging tools like 3D scanning and micro-CT scanning help scientists examine Neanderthal artifacts and remains with unprecedented detail, revealing patterns in their daily lives, diets, and even cultural practices. These techniques may help us understand not only how Neanderthals lived, but also how they adapted to changing conditions over time. The collaboration across scientific disciplines, combining archaeology, genetics, anthropology, and climate science, also opens up new avenues for understanding Neanderthals in a broader context. By examining how climate patterns, genetic adaptations, and cultural practices intersected, researchers can piece together a more comprehensive picture of Neanderthal life. This interdisciplinary approach holds the key to uncovering the factors that influenced their decline, and the extent to which Homo sapiens contributed to it. As technology progresses, the future looks bright for solving one of history's greatest mysteries. With each discovery, we get closer to answering not only why Neanderthals disappeared, but also what their story means for the broader human experience. Their extinction, or rather their fusion with Homo sapiens, teaches us about resilience, adaptation, and the interconnectedness of human evolution. In the end, the mystery of the Neanderthals isn't just about understanding the past. It's about exploring the possibilities of what it means to be human. The story of the Neanderthals isn't just an ancient tale. It holds valuable lessons that resonate in today's world. As we unravel the reasons behind their extinction, we gain insights into resilience, adaptability, and survival that apply to our modern challenges. Neanderthals faced environmental shifts, competition, disease, and the need to adapt to new circumstances. These are challenges humanity faces even today, albeit on a different scale. One of the most powerful lessons is the importance of adaptability. The Neanderthals were highly specialized for their Ice Age environments, with strong, stocky bodies suited to cold climates. But as the climate shifted and resources changed, their lack of flexibility in diet, tools, and social organization may have left them vulnerable. For modern humans, this is a reminder of the risks that come with over-reliance on specific resources, or rigid social and economic structures. In a world where climate change and resource scarcity are increasingly pressing issues, adaptability is more essential than ever. Another lesson is the value of cooperation and shared knowledge. Early Homo sapiens had larger social networks, which likely helped them innovate, share resources, and survive through difficult periods. This social cohesion provided a strong support system that may have given them an edge over Neanderthals. Today, as our world becomes more interconnected, collaboration and the sharing of information are powerful tools in tackling global issues. Just as early humans depended on community, we too benefit from collective action, whether in science, environmental efforts, or social initiatives. Finally, the Neanderthals' story highlights the fragility of even the most resilient species. Despite their strength, intelligence, and adaptability, they eventually disappeared. This serves as a sobering reminder that no species is immune to extinction. As we confront environmental challenges, health crises, and social changes, it's crucial to recognize that human progress and survival depend on how well we respond to these threats. Learning from the past, we have the opportunity to build a more sustainable future. In the end, the Neanderthals' journey reminds us of both the resilience and vulnerability inherent in being human. Their extinction is not just a cautionary tale but also a call to action, urging us to learn from history to shape a future where humanity can thrive for generations to come. The story of the Neanderthals offers more than just a glimpse into the past. It provides valuable insights into how humanity might navigate its future. As we consider the factors that contributed to the Neanderthals' decline, we can draw lessons about resilience, adaptability, and the critical decisions that will shape our future as a species. The Neanderthals' journey reminds us that survival requires more than just strength. It demands an openness to change, collaboration, and a proactive approach to the challenges we face. One key insight is the importance of preserving environmental balance. Neanderthals adapted to their Ice Age environments, but were heavily impacted by rapid climate changes and shifts in their ecosystems. This dependence on stable resources and habitats made them vulnerable when those conditions shifted. Today, humanity's own reliance on natural resources and stable climates puts us in a similar position. By prioritizing sustainable practices, we can protect the ecosystems that support life, ensuring that future generations inherit a world capable of sustaining them. Another insight relates to the role of innovation and technology. Early humans demonstrated a flexibility in creating tools and strategies that allowed them to adapt to diverse environments, giving them an edge over Neanderthals. In our modern era, technology and innovation remain powerful tools for solving complex problems, from renewable energy to medical advancements. However, the key lies not only in technological progress, but in using that progress responsibly and equitably. Balancing innovation with ethical considerations will be essential as we work to address global challenges. Lastly, the Neanderthals' story highlights the value of unity and shared purpose. They faced difficulties surviving in isolated groups, which may have limited their resilience in times of scarcity or change. In contrast, modern humans thrive on social bonds, collaboration, and shared goals. Today, global issues like climate change, pandemics, and resource scarcity require a collective response that transcends borders and cultures. By fostering a sense of shared purpose and prioritizing cooperation, humanity can better prepare for the future, just as early humans did through their social networks. As we look ahead, the Neanderthals remind us of what it takes to survive and thrive. Their story isn't just one of extinction but of the importance of adaptability, unity, and thoughtful action. If we can learn from their experiences, we have the chance to build a future that not only avoids their fate, but leads to a sustainable, interconnected world where humanity flourishes. The mystery of Neanderthal extinction continues to intrigue scientists and historians alike. With each new discovery, we come closer to understanding not only how they lived, but also why they disappeared. As technology advances and research methods improve, there are exciting possibilities for uncovering more answers. The future of Neanderthal research promises new tools, fresh insights, and a more complete picture of the forces that shaped their fate. One of the most promising areas of future research is ancient DNA analysis. Scientists are already making strides in reconstructing Neanderthal genomes, but advances in this field may soon allow us to analyze their DNA with even greater precision. These advancements could provide detailed information about Neanderthal health, disease, susceptibility, and adaptations to environmental changes. By comparing their genetic traits with those of early Homo sapiens, researchers may gain a clearer picture of what made Neanderthals vulnerable or resilient in their world. Another area of exploration is the study of climate and environmental data from Neanderthal habitats. Using sophisticated tools like ice core sampling and sediment analysis, scientists can reconstruct ancient climate patterns, providing context for the environments Neanderthals inhabited. Understanding these conditions in detail could reveal the extent to which climate fluctuations influenced Neanderthal survival. Did sudden temperature drops lead to resource shortages? Or did changing landscapes favor Homo sapiens over Neanderthals? These questions may soon be answered, as climate science continues to refine its methods. Finally, interdisciplinary studies combining archaeology, anthropology, genetics, and climate science hold great promise for deepening our understanding of Neanderthals. This collaboration allows researchers to explore Neanderthal extinction from multiple angles, integrating findings across fields to create a more comprehensive picture of their lives and eventual decline. By combining archaeological evidence with genetic data and environmental context, scientists can make well-rounded conclusions that single-discipline studies might miss. The future holds exciting possibilities for solving the puzzle of Neanderthal extinction. With continued research, we may finally uncover the events, choices, and circumstances that led to their disappearance. In doing so, we not only honor the legacy of these ancient relatives, but also learn valuable lessons about resilience, adaptability, and survival that apply to humanity as a whole. The story of Neanderthals isn't over yet. It's a tale that continues to unfold, one discovery at a time. If you found this video helpful or interesting, please give it a thumbs up and subscribe to the channel.